In this problem, we will see a very mathematical problem. It's called finding the power set of a given set. So what is meant by power set? It means that if you are given a set of some numbers, then you have to find all possible subsets that can be created from the elements of the given set. And the set of all those subsets is called power set. And the number of elements in the power set or number of subsets in the power set will be 2 raised to the power n, if n is the number of elements in original set. So we will see it recursively as well as iterative solution, and then I will give another solution using bit masking. So first let's understand what is a power set. So we are given a set, let's call it S, and it has 3 elements. So what are different possibilities? Either we pick first element or not. So either we pick it or we don't pick it. Either we pick it or we don't pick it. Similarly for 3. So let's take one of the paths. We don't pick this one. We don't pick this one. We don't pick this one. So we get an empty set. Then we pick this one. So pick true of this, false of this, false of this. So we get 1. So any possibility you can find. Let's say we want to form 2, 3. So here we took this path. Here we took false, that is we did not pick 1, true, true. So there can be 2 possibilities for 1, 2 possibilities for 2 and 2 possibilities for 3. So in total there are 2 cross 2 cross 2, that is 2 raised to the power 3 possible combinations or 8 combinations. So let's list them. So when we don't pick anything, this is empty set. When we pick one of the elements, then it can be 1, 2 or 3. Then we pick 2 elements. Then we get 1, 3, 1, 2 and 2, 3. When we pick all of the 3, we get 1, 2 and 3. So these are all the possibilities, and if you count it, 1, 2, 3, 4, 5, 6, 7, 8. So that comes out to be 8 as expected. So this is the meaning of power set. So the power set will be the set of all these subsets. So you see this extra bracket for set. So it includes all the subsets of this. This is power set. It's also denoted by P of S if S is the original set. So we will solve it. How we will solve it? Let's see. So let's say first let's look at the recursive solution. So we want to break this bigger problem into smaller problem. So how can we solve it recursively? Let's say we know the solution for, so we have to calculate the solution for 1, 2 and 3. So we break it into 1 we keep out, and 2, 3 is the smaller problem. So just take the first element out and solve for this. Again, take the first element out and solve for this 3. Now the solution for 3 is, we know that the solution for 3 will be this empty set and 3 itself. So this is returned back here. So what we will do in the calling function, so whatever is the solution for the original, the smaller problem, we will pick all the elements of that power set, keep them as it is, and add 2 to them, all of them, and append here. So this remains as it is. We are not removing them, but what we are doing, we are picking them one by one. So first we pick this, add 2 to it, so it becomes 2. Then we pick 3 and add 2 to it, so it becomes 2, 3. And this is the solution for this part, 2, 3. So this is returned back here. So what it will do, it will keep all of them as it is, that is 3, 2, 2, 3, and additionally it will take all of them and add 1 to it, the first element. So we will have 1. If 1 is added here, it will become 1, 3. If 1 is added here, it will become 1, 2. And if 1 is added here, it will become 1, 2, 3. And this solution is returned up, that is this solution, and this was the original solution, so it will return this value, and it includes all the possibilities. So what we are doing, if we are solving for S 1 to n, or if you are starting from 0 index, it may be 0 to n minus 1. So the solution for this is solution for, that is f 2 to n, solve for f 2 to n, and in that solution take the union of the same thing, f 2 to n, but append to it S1, the first element. So whatever is the solution, keep it as it is and append to it the first element. So that is a recursive way of solving it. The idea of iterative solution is very similar to this, and the same concept in fact. So what we will do here, we will initialize our result to consisting of an empty set. So this is initialized, and what we will do, we will iterate for all the elements of this given set. This may appear to be easier to you. So for n in S, so we are looking for all elements of n S. So what we do, whatever is the existing result, we append this n to that. So result is empty, so what it will do, it will append to it. So result equal to result union n plus the elements of result. So what it will become, so initially n is, so first n is 1. So what it will do, result is empty, so take the result and append to it, append to all the elements of this number n, which is 1. So just one element, so just this is appended. When n becomes 2, that is we take the next value of n, so this is for all the elements of this set. What we do, we take this result, this is result, we don't delete the existing ones, we have to just keep appending values. So what we will append, take this one, add 2 to it, take this one, add 2 to it, and this is the result when we have processed n equal to 2. Finally, the last number is 3, so n equal to 3, so keep it as it is. We will not be copying, we will be using a common result, we will be just appending to that. Here I am writing it again and again for keeping it clean. So this is the result. Now what is our job? To iterate from first element till the last element of result, and before iterating, keep the size here, because you will be inserting to that result only, so its size will keep increasing. So take the size beforehand. So we have 4 elements, so we will take first 4 elements of the result and add 3 to it and push it back. So in this, if we add 3, we get 3. In this we add 3, we get 1 3. In this we add 3, we get 2 3. And in this we add 3, we get 1 2 3. And now we have iterated for all the value of n in this set, and this is the final result. So you see, it looks much more cleaner and much simpler. But if you are able to solve this recursively, then it would be a good practice for understanding the recursive concept. Finally, let's see the third method, which is using bit patterns. So here we have 3 elements, and we know that if we use 3 bits, that is B2, B1, B0, let's say these are 3 bits, then using 3 bits we can form 8 numbers. And what are those possibilities? 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, and 1 1 0, and 1 1 1. 1 2 3 4 5 6 7 8. Exactly same concept. Each bit can be either 0 or 1. So there are total 8 possibilities. So these are the possible values for each of the bits. This is exactly same thing we had seen these branches. It can be true or false, and that is 0 or 1. So 8 possibilities are there. So you convert this, you list down all the bits represented by this 3-digit number. That is, this is number 1, this is 0, this is 1, 2, 3 till 7. So if you have 3 elements, then you know that it can represent 8 possibilities are there. So you iterate from 0 to 7, and whatever is the bit representation of this, which will be this, iterate through these characters. So all of them are 0, so don't include anything. Then I will be 1, and in 1 you see that this character is 1. So what you will do, you will pick this element at this index, third one. So it will be 3. Then in this I equal to 2, we see that second bit is 1. So take just second number. Then when I equal to 3, then these two are 1. So take these two, that is 2 and 3. In this case, this one is 1. So take this one. Here first and last are 1. So take first and last, that is 1 and 3 in this element, in this set. Then here these two are 1. So take 1 and 2. Here all 3 are 1. So take all 3, 1, 2, 3. And you see this is also the power set. So try solving it in C++. At least I know you can use bit set, and you pass this number from 0 to 2 raised to the power n minus 1, and convert it to a string, and then check which character are 1, then pick those indices from this. So let me solve the recursive and iterative solution, method 1 and 2 in C++, and later we will just continue with iterative solution in Java and Python. So this is the problem. I had taken the same example. So if nums dot size or nums is empty, then return this empty set should be there. This null set should always be a subset. So you cannot simply return this. It should be this. There would be one element. Otherwise, we will create a vector for result. This is the return type. So first I am writing the recursive solution. So let's call the recursive function subsets rec, and we will pass this nums and one index. So initially it will be 0 to last element, and then recursively it will call from 2 to last index, 3 to last index, and so on. So here we will pass 0, and let's pass result. So result will be populated, and finally we will return result. And now we will define this function. So if this is the last index, that is there is only one element, then we know the solution for this. Result dot push back this empty set, and also there is just one element, so push that element. These are the two possibilities. else we will call it recursively. So this will recursively call smaller and smaller problem. Ultimately it reaches the end, and then it will start returning, and it will be inserting into this common result which we are passing by reference. So now we will take the size. So this recursive call has done it for all the smaller values. Then we iterate through all the values, all the elements of this result, and then append it to it the current element, that is IDX, and then also insert it into the result. And this matches the expected solution. This ordering is not important in sets. These can be in any order. So let's submit. And this solution is accepted. Now we will see the iterative solution. So what is the time complexity here? We will compare the times for recursive as well as iterative solutions. So let's understand the time complexity first. So what we are doing, we are taking an empty list and appending to it one element. Then this size becomes 2. Then in the next step, what we are doing, we have 2 and we are adding 2 to each of them. So its size now becomes 4. Then we are taking third element and adding 3 to all of these and pushing to the result. So this is done 4 times, this is done 2 times, this is done 1 time. So 1 times 2 raised to the power 0 plus 2 times 2 raised to the power 1 plus 3 times 2 raised to the power 2 all the way up to n minus 1 times 2 raised to the power, or n times 2 raised to the power n minus 1. So what is this sum? Let's call it S. Then this is, let's write it 2s. Then what will be 2s? If we multiply 2 to it, it will become 1 times 2 raised to the power 1. So let's write it here. Then if we multiply this by 2, it becomes 2 times 2 raised to the power 2, and so on. And here it will be n minus 1 times 2 raised to the power n minus 1. So we are writing this same thing. We are multiplying each term by 2 and we are writing one place to the right. So this multiplied by 2 comes here, this multiplied by 2 comes here, and so on. And this will go here. So if we multiply 2 here, it will be 2 n times 2 raised to the power n. And now subtract this from this. So it will be minus s. This will be 2 raised to the power 0. This here powers are common and constants are a difference of 1. So this is 1 times 2 raised to the power 1. Similarly here it will be 1 times 2 raised to the power 2 plus 2 raised to the power 3 and all the way up to 2 raised to the power n minus 1. and this is minus n times 2 raised to the power n. So this is a geometric progression till here. So let's take the opposite sign. So s becomes n times 2 raised to the power n. This term, it becomes positive, this becomes negative. So what is the sum of this? Here first term is 1. It's 1 plus 2 plus 4 plus, and there are in total n terms. So a multiplied by a is 1. So 1 multiplied by common ratio is r, which is 2. Each is increasing in the factor of 2. So 2 raised to the power n minus 1 divided by 2 minus 1, that is 1. So what is this term? N 2n minus 2n plus 1. So take 2n common. So n minus 1 2n plus 1. So you can ignore this in time complexity analysis, and this n minus 1 you can think of it as n. So it's of the order of n times 2 raised to the power n. So this is the time complexity, and similar is the space complexity. Since we are storing 2 raised to the power n subsets are there, so there is no way to get out of that. You have to return a set of all those subsets, and in between we are copying elements in a temporary variable and then copying to the original result. So it's also of the same order. Now let's write the iterative solution. So let's comment it out. And let's initialize it to empty solution. So just what we saw here, we initialize with empty set, then for all the elements of S we append to them this element. It's very similar to, in fact, this logic. And this solution also matches, so let's submit. And this solution is accepted, and here it's much faster. You can try a few times, it can be 0 millisecond as well. Now we will write it in Java and Python. and the Java solution is also accepted. Finally, we will do it in Python. And the Python solution is also accepted.